Hey everyone, and welcome to today's Explainer. Today, we're unpacking a mystery that's literally hiding in plain sight right above our heads. We're talking about the science of contrails. We see these brilliant white trails crisscrossing a clear blue sky almost every single day, yet, honestly, very few of us stop to ask what exactly is going on up there. Okay, let's dive into this and uncover the fascinating atmospheric physics that actually paint our skies. Seriously, have you ever looked up and wondered why airplanes draw those long white lines across the sky? It's an incredibly common, everyday visual phenomenon. And today, well, you get to play the role of an everyday detective. We're going to solve this high-altitude mystery together. By the time we finish this explainer, you're going to look at the sky in a completely different, much more informed way. So, the absolute best place to start solving our mystery is with the word itself. Contrail isn't just some random aviation jargon. It's a portmanteau. That's just a fancy way of saying it's two words smashed together: condensation and trail. So it is quite literally a trail of condensation. But to truly wrap our heads around how that condensation happens in the middle of a totally empty sky, we have to look at where it all originates. Which brings us to our first major point. Inside the jet engine, the catalyst. Just like the car you drive, an airplane burns fuel to move forward, right? And as a result, it produces a specific type of exhaust. The core ingredients of this jet engine exhaust are intense heat, water vapor, and tiny little particles like aerosols and soot. These three ingredients are forcefully blasted out of the back of the aircraft. But here's the kicker. On their own, they are completely invisible. Something else has to happen to them to create that dramatic white line we actually see from the ground. Now, let's look at part 2, the freezing high-altitude clash, or the environment. When commercial airplanes reach their cruising altitude, which is usually somewhere around 30,000 to 40,000 feet up, the air outside is drastically, aggressively cold. We are talking negative 40 degrees Fahrenheit. To put that into perspective, that is the kind of mind-numbing cold that freezes water literally instantly. So we have an environment that is freezing cold and an engine that is blasting out intense heat and water vapor. When those two extremes meet, a super rapid chain of events happens. First, the hot exhaust leaves the engine. Second, it instantly meets that negative 40-degree air. Third, the water vapor in the exhaust rapidly condenses. And finally, step 4, it freezes into billions of tiny ice crystals. The best way to visualize this, think about stepping outside on a freezing cold winter day. When you exhale, your warm, moist breath meets that freezing air, and boom, you instantly see a white cloud of condensation. A contrail is exactly the same atmospheric thermodynamics at work, just on a massive, high-altitude jet-powered scale. You're basically looking at a giant river of man-made ice crystals. Moving on to our next section, why do some linger? The variables solved. Now, you might be wondering, if all commercial planes burn fuel and all planes fly high up in that freezing cold atmosphere producing this ice crystal exhaust, well, why don't these trails always look or act the exact same way? I mean, sometimes you see a short little tail behind a plane, and other times a thick white line stretches literally from horizon to horizon. So why the difference? The answer actually isn't the plane at all. It's the invisible air around the plane. Atmospheric humidity acts as our ultimate wildcard here. If the air is dry, meaning low humidity, the ice crystals in the contrail quickly sublimate. That just means they turn back into an invisible gas, and the trail is super short-lived. But if a plane flies through a pocket of high humidity where the atmosphere is already packed with moisture, those ice crystals survive. They become a persistent contrail that lingers and actually begins to spread out across the sky. This leads us to our final section, the bigger atmospheric picture and its global impact. Under the right high humidity conditions, these persistent contrails don't just sit there as thin lines. They catch the upper atmosphere winds and start to spread horizontally. Over just a few hours, a single contrail can expand to become a massive, artificial, sprawling cirrus cloud. What starts as a simple stream of exhaust from one jet engine can fundamentally alter the actual cloud cover and even the amount of sunlight reaching the ground over a given area. It's an absolutely incredible chain reaction triggered by a single flight. So we've solved the mystery. A contrail isn't smoke, it isn't pollution dropping on us. It's essentially a man-made, high-altitude ice cloud formed by extreme temperatures. So I want to leave you with this question to think about. The next time you step outside and look up at a plane flying overhead, what will those trails tell you about the weather up high? If the trail vanishes quickly, you'll know for a fact the air up there is bone dry. If it stretches across the entire sky, you'll know it's incredibly humid miles above your head. You now have the scientific understanding to read the sky completely differently. Keep looking up, keep asking questions, and we'll catch you next time for another explainer.